Welcome back to the AI Research Roundup. I'm your host, Alex. Today is June 17th, 2025. Alright, so fresh off the press from yesterday, we have a paper from Hugging Face's trending list called MiniMax-M1, Scaling Test Time Compute Efficiently with Lightning Attention. This paper introduces a new open weight model, MiniMax-M1, that tackles the challenge of computational cost. It uses a hybrid mixture of experts architecture, which is like having specialized mini-models that activate only when needed, combined with a new lightning attention mechanism to process huge inputs and think for longer, very efficiently. Also, the authors have made their work available on GitHub, and it's quite comprehensive. You'll find the open weight model files, of course, along with detailed deployment guides for both VLLM and transformers. They've also included instructions for using the model's function calling capabilities and the full technical report. Alright, so let's look at the first set of results. On the left, we see a bar chart comparing MiniMax-M1 against top commercial and open models on really tough benchmarks, things like competitive coding and software engineering. You can see the red bar for MiniMax-M1 is right up there with the best. But the really striking part is on the right. This line graph shows the computational cost measured in flops, which are basically the number of calculations needed. The much lower red line for MiniMax-M1 shows it's incredibly efficient, especially as it generates longer responses. Building on that efficiency, this next table really puts the scale of MiniMax-M1 into perspective. It compares the maximum input and output lengths, measured in tokens, which are essentially small pieces of text, for several top models. You can see MiniMax-M1 handles a massive 1 million token input, its context length, matching Gemini 2.5 Pro. And its maximum output, or thinking budget, is 80,000 tokens, giving it a huge amount of space to generate long, detailed, and reasoned answers, surpassing many of its competitors. So how did they achieve this? Well, a key part of the answer lies in their training method. This chart shows the effectiveness of their new reinforcement learning algorithm, which is a method for training an AI by rewarding it for good answers. Their specific algorithm is called CLIPPed-IS Weight Policy Optimization, or CISPO. You can see its performance in red. It consistently outperforms the other methods, and as the arrow shows, it achieves the same performance as the next best approach, but with only half the training steps. This 2x speedup is a big deal. Now, scaling up this reinforcement learning wasn't entirely straightforward. These next plots show a key technical challenge they overcame. Each plot compares the model's token probabilities during training versus during inference, which is when the model is actually generating answers. Ideally, these should be identical, with all the points falling on that red diagonal line. On the left, you can see a mismatch, but on the right, after applying a fix, using more precise FP32 calculations at the final output stage, the points are much tighter and the correlation is nearly perfect. This stability was essential for the model's performance. Okay, so with that training process stabilized, this table lays out the final benchmark results. It compares the two MiniMax-M1 models against both leading commercial or closed weights models and other open weights models. Closed weights just means their internal parameters are private, while open weights are publicly shared. And you can see MiniMax-M1 is highly competitive, especially in software engineering and long context tasks. It also excels at agentic tool use, which is its ability to use external software, even outperforming some top commercial models. The results clearly validate their approach. And these next graphs give us a fascinating look at how that reinforcement learning process unfolds over time. Across 3 different reasoning benchmarks, like AEM and Live Code Bench, we see 2 lines plotted against the training steps. The blue line is the model's accuracy, and the orange line is the length of its generated answer. What's really clear is that as training progresses, both lines trend upwards together. This shows the model is learning to use longer, more detailed chains of thought to solve these complex problems, and that this longer reasoning directly improves its performance. So what we're seeing is a direct link between the model's ability to think longer and its ability to get the right answer. In conclusion, MiniMax-M1 really pushes the boundaries for open weight models. The key innovations are its hybrid mixture of experts architecture, which uses specialized expert modules, combined with a new, efficient lightning attention mechanism. This pairing allows for massive context lengths and highly detailed reasoning. And it's all powered by that novel reinforcement learning algorithm, CISPO, which ensures stable and efficient training. That's all for this AI Research Roundup. Thanks for listening.